Hello everyone, my name is Haroon and I'll be explaining you how to find the complementary function of a differential equation of second order of this format. Now this is a second order linear differential equation. So it says that the second derivative of y with respect to x plus p, the derivative of y with respect to x plus q, y is equal to r. So I may assume that the derivative with respect to x as lambda. Now this equation becomes lambda square y plus p lambda y plus qy is equal to r. Now if I take y common, the equation becomes lambda square plus p lambda plus q as y is equal to r. The complete solution of this equation has two parts. The first part is the complementary function and the second part is the particular integral. I'll be explaining you how to find the complementary function. So this I can also write it as y is equal to the CF complementary function plus PI particular integral. So the complement, I am naming it the complementary function as yc just to ease things upon me. So y is equal to yc plus yp. Now yc has three cases. If you get this equation, you can easily find the roots of this equation. Now when the roots are real and distinct, that is m and n, you get yc is equal to c1, that is the constant 1, e to the power mx plus c2 or constant 2 e to the power nx. Now you may interchange the values as c1 e to the power nx plus c2 e to the power nx, it doesn't make a difference. So that's it, that's our yc. Now the second case says that if roots are real and same, that is m and m, the yc will be c1 plus c2x e to the power mx. Now don't forget to add an additional x when you go along the chain. Now let's say if I add another m, like 3 roots that are repeating, so this equation becomes plus c3 x squared e to the power mx. You may get the idea what I've done here. Alright, so the third case says that if roots are imaginary, that is in the form a plus minus b iota, so the yc will be e to the power ax. Now a is the real part of this of the root, and then comes the c1 cos bx, b is the imaginary part, plus c2 sin bx. Now no matter what the signs here are, this plus sign will not change. Whatever comes over here, it doesn't change. So that is your yc. Now if the imaginary part, the real part is minus a, this becomes a to the power minus ax. That's it. That's how you find the yc. Now case 1 is for real and distinct roots. Now the question says that the second derivative of y with respect to x minus 3, the derivative of y with respect to x plus 2y is equal to 0. Assuming the derivative with respect to x as lambda, we get this equation lambda square y minus 3 lambda y plus 2y is equal to 0. Now taking y common, we get the equation lambda square minus 3 lambda plus 2. Now we solve only this equation to get our roots. I solve this equation by middle term breaking and I get two roots, 1 and 2. Now these are real roots and distinct. So the formula for yc is c1 e to the power 1x or just simply x plus c2 e to the power 2x. Now this is for when roots are distinct. What if roots are real and repeated? Here comes case 2. The question for case 2 is that the second derivative of y with respect to x minus 8, the derivative of y with respect to x plus 16 y is equal to 0. Assuming the derivative with respect to x as lambda, our equation becomes lambda square y minus 8 lambda y plus 16 y is equal to 0. Taking y common, our equation becomes y lambda square minus 8 lambda plus 16. Solving this for our roots, we get two roots that are same, lambda as 4 and lambda as 4. Now for same roots or for case 2, the formula for yc is c1 plus c2x bracket close e to the power 4x. This is how you solve it for case 1 and case 2. Now, when roots are not real, they are imaginary. Here comes case 3. The question for case 3 is the second derivative of y with respect to x plus 4, the derivative of y with respect to x plus 5y is equal to 0. So that we assume lambda as the derivative with respect to x. So this equation becomes lambda square y plus 4 lambda y plus 5y is equal to 0. Taking y common, we get y lambda square plus 4 lambda plus 5 is equal to 0. We solve this equation for to find roots. I apply this quadratic formula to this equation and get these roots, minus 2 plus minus iota. So the formula for YC of imaginary roots or case 3 is e to the power minus real part x or minus 2x e to the power minus 2x bracket c1 cos imaginary part x or 1x plus c2 sine imaginary part x or 1x bracket close. Thank you for watching.